Okay, so the software testing tool that we have chosen for this particular discussion is LEAPWORK. So we know that software testing is an important part of software engineering where we test for any kind of errors or bugs that are present in the code so that user doesn't have to experience uh, any difficulty in performing this process. But what happens is software testing is a very huge process. It takes a lot of time, it takes a lot of resources, a lot of human resources are involved in performing the software testing. And so what happens is software testing takes a lot of time and the product takes a lot of time to get into the market. So in order to prevent those amount of time getting wasted on software testing, a lot of automated testing tools are being developed and employed into the market so that the amount of time and human resources spent is going to be less. So out of all those automated software testing tools, the one software testing tool that we're going to be talking about is going to be LeapFrog. So as you know, software testing, in layman terms, software testing refers to the process of verifying and validating a system. It identifies the errors, bugs, and engine functional and non-functional requirements, if any, so that the errors and the missing functional and non-functional requirements can be resolved at an earlier stage. And the software testing process happens all over the project development cycle. And so, in order to prevent the amount of time being spent in software testing and to reduce the amount of resources being spent, we are using a lot of automated software testing tools. And as I said, the one such tool is going to be LeapFrog. So, LeapFrog is an automation platform that is used for automation testing that enables users to build and execute a set of user-defined or predefined test cases to a series of automation tests in the form of flows and process automation. The flows that are designed here are visualized using uh, kind of building blocks that are also called as nodes, and each representing one particular operation. Like, for example, click element, or you're going to be starting an application, or you're going to be opening a browser and finding a web element, etc. This creation, configuration, and maintaining of automation flows are done through an easy-to-use designer called as LeapWork Studio. So LeapWork Studio is basically the software on which the software testing process flows are being created, designed, and deployed. So LeapWork Studio actually makes testing and process automation visually pleasing and interactive for everybody on team, so that everybody present the contributing for software testing can easily visualize the software testing process and can make changes as in time as they go. So when you come to LeapFrog, one of the most important things that needs to be taken care of is going to be about organizing your work. Since you are now familiar with what LeapWork actually does and why it is being used extensively for automation testing, we are going to be diving deep into getting familiar with navigating the software and understanding the common terminologies used while working on it. So the common terminologies that we are going to be covering in this particular recording is going to be about flow menu, folders, flows, subflows, locators, and design canvas. These six terminologies are going to be the most used terminologies and the most used tools in using the LeapWork automation tool. So coming to the first one, flow menu. Flow menu is basically it talks about having a file explorer or find this file explorer kind of hierarchy format consists of all the flow related assets like flows, reusable subflows, web, desktop elements, and much more. The flow menu is available from the main menu that is present in the LeapWork Studio by clicking on flows. The main purpose of having this flow menu is actually used to organize and perform more operations productively, that is saving our time and energy to focus on the important aspects of testing. Coming to the folders, the flow menu has some kind of sub form of hierarchy called as folders, and all these folders are represented in the form of a tree view structure. And these folders are the main key to organizing the automation flows and related assets. Every single flows and every single subflows that are related to one another are being kept in a related in a related folder. So if you want to create a folder, you can either do it by clicking new and selecting folder. and this will create a folder at the point of focus in that review. That means the folder will be created at a point where your cursor or your highlighter is being pointed, and you can also perform this operation by right clicking anywhere in the trivia and clicking on new folder. You also even have the facility to rename this folder while creating it. So coming to flows, the core of the LEAPWORK automation tool works on a concept called as flows. Flows, or it's also called as process automation flows. So in test automation, a flow is nothing but a test case that gets executed. A flow basically describes about a test case that is being executed. It also describes about the test case on how every single aspect of a test case, starting from the start of the test case till the uh, describing about the success or failure of a test case. Everything is being described in the form of flows. Flows can be created in two ways, either by clicking the new button from the top of the flow section and then clicking new, or by as usual right clicking on a flow and clicking on new flow. So once a flow is created, you'll be having the option to create it again. Now it is not located in the right folder. Simply drag and drop into the right position. All assets within a automation flow, that is subflows and all the captured elements, can be arranged in right clicking on right. This way you'll be able to have an overview of which assets belong to which flow and make it an easy to move flow including all the 6 services. So coming to subflows, we know what a flow actually means. A flow is basically a top level overview of how this case is being executed. So when you come to subflow, a subflow is similar to a flow. What happens is a subflow is a flow within itself. So subflow is an automation flow that can be reused as a component inside other automation flows. So the main use of having a subflow is basically this is similar to having creating an object in any of the programming. You'll be able to reuse the subflows whenever and wherever you want. You don't have to create the same logic every single time when you want to apply this logic. You just need to drag and drop the subflow in the required canvas that will be implemented, and the process will run smoothly. So using subflows is considered best practice because it allows you to encapsulate functionality that is similar to object oriented in global components, making maintenance much easier, and you will be able to visualize the process of flows in a much neat and detailed manner. A subflow can be created in two ways, either by clicking new and selecting subflow to begin working on an empty subflow, or by creating the subflow from an existing automation flow by selecting the building blocks to be used as subflow, right clicking and then clicking create subflow. So after naming a software is then added as an asset. Like it is being considered as an asset for a flow in that review and can be reused in any of the LEAPWORK automation flows. Coming next to the locators. Locator is basically nothing but a piece of uh, software automated element. What it does actually is it is used to locate every single element that is being present on a web or a desktop or any other remote machine. So Locators' main purpose, part of designing automation flows, is to capture elements in the application under automation. So whenever you do automation, you need to know which elements are being present there. So in order to identify those elements and name those elements using their IDs, you use locators. In LEAPWORK, this means fetching some information about an element in the application. Example, the ID of field in a website, the name for button, the area contains specific text, and etc. These elements are called locators and are essential part of automation flows. They contain information used during the execution of automation flows to find and manipulate the given element. So whenever you use locators in order to find and manipulate a particular element. Can be either a web element or a desktop element, so that you'll be able to perform certain kind of test case operations automatically. Almost any software can be automated using LEAP, including local application, mobile website, desktop application, etc. like Citrix, etc. Automating different kinds of technologies creates different kinds of locators. So every single technology that is being employed uses a different kind of locators for its main purpose. Some of these examples is given as web elements. So when you have a website, and if you want to automate the testing process of the website, use a lot of web elements in order to describe the web element and identify which web element is being used using an ID. Desktop elements include contains hierarchy of the desktop control. Images like OCR are being used in order to find the key elements that are being present in a virtual machine image. Collection include a list of images that are being collected, similar images that are being captured and collected in a collection and to perform certain operations. And data files also include CSV and XLS, Excel sheet, Word, etc. Coming to the design canvas, whatever work, whatever kind of whatever flow or whatever test case operations that you're going to do, you're going to be visually looking at it in a canvas called as design canvas. So, as the name suggests, it is meant to be used as a canvas for all our flows. So, every single block and every single node that is being dragged and dropped in a flow, you'll be able to visually see it in the design canvas. So, when you drag and drop all these different kinds of nodes, and when you try to create a flow, um, and when you try to connect all these blocks together, you will be having a tool called as a connector. So there are two different types of connector, and these two different types of connector have been represented using color code. So one is going to be green and one is going to be blue. So the green connector here represents the direction of the process of this execution. Say for example, you want to start a particular process. So whenever you create a design flow, it always starts with a particular node called as a start node. So start node actually starts a particular design case execution. From the start node, you wanna perform a test case operation for a website. So from the start node, you create another node called as a website node that is used to visit the website and collect the required website elements. So in order to make the process flow from the start to the website, you use this green connector. So when you hover over the particular node from where you want to jump, you'll be having both green and blue connectors. So when you click on the green connector and you drag and touch the website node, there will be a connection being formed between the start and the website node. That green connector from the connection helps you to define the direction in which the process is being flowed. Next comes the glue connector. So the main purpose of this glue connector is it's actually used to transfer a data or a value from one particular node to another particular node. Say for example, you perform a process in which you collect data from an Excel sheet and you want to display this data in your log files. So what happens is when you collect the data from Excel sheet, you will be using a specific type of node in order to collect the data from the Excel sheet. So when these data are being collected from XMC, you have to pass these data or values from one particular node to another particular node. So in order to pass those values from one node to another node, you use a connector called as view connector. So since now we are now familiar with the basic terminologies and tools being used in LeapWork, we will be diving deep in
டேய் நான் சொல்லணும்டா.
sorry, you'll be talking about it. So
Thank
you'll be now diving deep into the process of how you'll be working with Leaper. And so the process of working with Leaper will be explained by Suresh now. So I transfer it over to you, Suresh.
Thank you, Vishnu, for your presentation. The previous slides, we have seen the basic terminologies which are used in the LeapWork testing process. So we will be looking how the LeapWork works. Basically, the LeapWork will be working into three process. The first one is design automation flows, then agents, and then comes the run list. First, we will see the design automation flows. Next slide. With respect to the LeapWork automation, the automation designed as flows. The flows in the technical terms, the flows is referred to as test case. Design the automation flows is done in the flow modules of the LeapWork Studio assets from the main menu. Flows in the LeapWorks are designed by connecting and visual building blocks, each representing and performing the set of operations as we seen in the previous slides, like clicking the element, starting the application, finding the errors, and etc. By default, when we start the testing process, the newly created flow contains just one building block that denotes the start block, which is located in the design canvas, which you already seen in the previous slide. The start block denotes the denotes to start the whole process. and every other block following is executed in a sequential fashion. Once the blocks are created and connected, a flow process takes by executing the each test cases. Then, following execution is an important part of the automation flows, and then it comes to the verification part. Next slide. Uh, then you will be building the verification part into the testing tools the using the building blocks. Then we can add in the pass building blocks. If if the verification is successful, then we'll be adding the pass building block. Let's take an example. Consider a login process of an application or web application. After entering the login credential and clicking on the login, the verification will consist of finding something in the application that confirms the successful login with respect to the connecting to the database. It could be the name of the user logged in or the appearance of the given menu element, etc. Then, if a flow runs or proceed in without hitting a pass block, then the flow runner's default considers to be failed. This could happen if a given element or state is not obtained, like in the case of the failed login. Leaper comes with a special feature called failed building block, but you don't have to add it to the handle to all the signals which have been failed. If a pass block signifies the end of a specific execution, then all other execution scenarios will be by will be by default logged or as failed. Then, but if you want to perform a series of some operation again and again, the again and again means it denotes the looping process. But with the input value change, looping helps the get the job as much as reliable and fast. Running through the list of values rows in a table, the list of identical, etc., is preferred as an automation flows. With the LeapWork, a visual flowchart approach is usually done to represent the LeapWork process. Then we have a lot of ways in the loop building block. The simplest way of the loop building is the loop building block. It simply run through the list of numbers from minimum to maximum. For example, for from starting 1 to 10, the building block will trigger the top green connector. As we seen in the previous slide, the green connector used to represent the direction of the flow and the process and text execution and other etc. Then we have touched two screenshot for your reference. In the example, in the example shown, the log message build block is executed 10 times. Each time the recording the current number in the activity log. All the logs will be stored in the activity log. Then after all iterations done from 1 to 10, the completed green character is triggered and the pass building will be executed such that it signifies the using a loop block. Driving automation flows using a data from central from the external resource is powerful, and it is a common discipline in the automation process. This makes the individual automation flows from more flexible and capable of covering more scenarios in an efficient manner. And furthermore, the flow does not need to be changed to handle other data. This is handled in the data repository where the data have been stored. Using the read Excel building block to read the data from the Excel sheet on a local drive. Use the data directly into the flow. In this case, the data entries are used to store the set of values in the desktop application. Beside the Excel sheet, we can also integrate using the database, the web service, and powerful scripts. Mostly, the Excel sheets are used in the testing. Then comes the agent working methodology. In the agent, in the when it comes to the agent working methodology, the LeapWork supports the execution of automation test flows on a remote computers. Basically, when it comes to remote computers, the remote computers can be defined as the computer that has a user no access to physically, but may be able to access it using the remote from one link to from via the link from one computer to another computer. The remote connections are made through use of a network which connects the computer and the device that user access it. And then the LeapWork automation platforms, the agents are available via the various modes like machines, computer, device, and based on the comfort zone, the flows can be executed. The defined agents can be used in the setting schedules. The agents will be giving some set of schedules when the different stages of testing will happen. Then the leapbooks will be comes up with the different types of agents, and they are categorized into five types, which are listed below: remote agent, source labs, browser stacks, selenium grid, and grid elastic. Excellent. And then the last methodology comes here, there's a run list. A run list is a collection of one or more automation flows that executed one or more time. Basically, the run list is a collection of one or more times that execute multiple times based on the schedule. The execution of the control, the execution part is controlled by the Leaper controller, and the run list are used in many scenarios in the industry. The scenarios is given below. The executing the larger collection of test automation flows against, for example, development and test automation, growing in a flows in steps and controlling the test execution, growing in the flows in steps and controlling the test execution order. For example, we can test this. Example, we can test in the software development cycle. Running one or more information flows to trigger a business process on a timely basis. Based on the given time zone, we can complete the testing with a stipulated time. Exiting the automation flows through the public REST API, and then the executing the automation flows through the continuous integrity and development pipeline. This is the one of the architecture method used in the testing process. Then the executing the same automation flows in the different configuration and the environment. Different configuration, then different in the executing this testing in various products in different industries. For more details regarding the LeapWork, check out the documentation part, which and we have given the link for your reference. Thank you.
So thank you, Mr. Esma. So this recording is going to be a brief overview of what LeapWork actually is and how LeapWork is being used as an automation tool for a lot of testing test cases, and how LeapWork saves a lot of time in testing and human resources. So thank you.